Alright, shall we have a go at this? So cos inverse, do you remember what it looks like? It's the one where it's from 0 to pi, right? So that's why I'm just above the axis. So, let's see here. Not that it's the point, but don't forget that when you're drawing cos inverse or sine inverse, just like if you were drawing sine or cos, the stationary points they should have horizontal tangents, right? So here, you ought to have vertical tangents, but anyway, that's a minor point. Okay, so there's y equals cos inverse of x. X equals a half. Where is that? Well, the domain of cos inverse and sine inverse is domain. What's the domain? -1 to 1. So here's -1, and here's 1. Okay, there's our intercept. Okay, so they've given us the line x equals a half, which is this vertical line here. Okay, happy? And the x and y axes. So the actual area I'm interested in, I'm going to do this carefully, is this one. Okay, so when you think about how to solve this, there are some problems. Because normally we would find the area under a curve just by integrating, right? So you would do this. Integral from 0 to a half of this graph, which is cos inverse of x. So great, okay, except for the problem that we don't know what the integral of cos inverse is. It's weird, by the way. You can go Wolfram Alpha and look at it, and it's strange. We can differentiate cos inverse, but we cannot integrate it. All right. So therefore, you must approach this area in some other way. Okay. Now, when you're thinking about areas and trying to get sort of different approaches on it, not just using the regular or integral that's standard. Okay. There's lots of different ways to skin a cat. So I'm just going to show you the first way that came up to. Okay. It's a common figure of speech, guys. I'm just going to give you the first one that came to me, okay? So, have a look with me. Remember, this is just regular cos, or if you like, just like sine, but shifted, except it's sideways, okay? So, I want you to look at it, and rotate your head this way. Okay, so look at it this way. And, well, how would I work out that area? Well, that area consists of two parts. Firstly, if I draw a line across here, can you see that? Look at it sideways, okay? You've got a rectangle there. Rectangles are fun. We can deal with rectangles, okay? And then you have this little sort of wimpy part here, okay, very small. How do you deal with that? Well, you can come up with any integral you like that will give you an equivalent area. Any one you like, okay? Remember, sine and cosine are really the same graph, just moved around. So the first one that came to my mind was, well, if you look, again, turn your head, right? And I'm starting from here and I'm going forward. That looks to me like sine. Doesn't that look like sine? Like if I covered this, okay? That's the beginning of sine and then it comes down and it keeps going, right? So the question is, what part of sine is it? Okay? Well, let's come back. This is cos inverse, right? So what's this intercept in here? Cos inverse. This is pi on 2, right? Because the whole range is pi. Okay, so halfway. Now, if that's pi on 2, what's this value here? This is cos inverse of a half, right? Because the x value is a half, so therefore this coordinate here should be cos inverse of a half. What's cos inverse of a half? What angle do I need? I take the cosine of it and I get a half. Answer? Pi on 3, right? Okay, now one more question. I'm thinking about this like sine, because when I look at it sideways, I'm like, I want the first part of sine. I'm just trying to work out how much. So, how much? What's the difference between pi on 2 and pi on 3? It's pi on 6, right? Because pi on 2 is just 3 pi on 6, and pi on 3 is 2 pi on 6. So pi on 6 is the difference. So now, when I think about how do I work out this area, and I gave them names in my solution. I called this A, and I called this B. Okay? You can state area A is equivalent to the integral from, now I'm thinking in terms of sine, right? Just not sine inverse, just regular sine. It's from 0 to pi on 6 of sine x with respect to x. Because I'm integrating horizontally, not vertically, okay, like this is. Right? Now you can all do this for me. What's the integral of sine? Minus cos? Yeah, it's easy to get mixed up. So that's that, and then you evaluate it, okay? So minus cos of pi on 6, that's minus root 3 on 2, right? Minus root 3 on 2, yes? And then you have to take away minus cos of 0. Minus cos of 0 is 1, so this is minus 1. Okay, so this area, that little, that little wimpy bit at the top is 1 minus root 3 on 2, area A, okay? Now you work out the other area. It's a rectangle, so what is its width and what is its height? Its width is half a unit. Right? And its height, we already established, is pi on 3. So that rectangle is pi on 6. So therefore, it's weird, but pi on 6 plus 1 minus root 3 on 2. Units squared. Okay. So you see, right, this is a really good, it's a clever question because it's trying to sort out, you try and think from the exam setter's point of view, it's trying to sort out people who just sort of blindly go in towards integrals, because that's how we usually work out the area under a curve, right? Between the people who think, oh cool, I know how to integrate that, and differentiate it. And then the people who look at it and they know they can't do it, but they're like, oh, I don't know. And so this is really a question of, can you see this is an area you're actually very familiar with, okay? So, yeah.